Today we're going to discuss how the mass of an object affects acceleration. Now, in order to understand, we have to realize that in this scenario, force is going to remain constant. The force applied is going to be the same for all the different shopping carts. We have a 400 kilogram shopping cart. We throw a bunch of groceries in and increase the mass of the shopping cart to 800 kilograms, and we fill it up even more to increase the mass to 1200 kilograms. So the variable that's being changed is the mass of the shopping cart. So how does that affect the rate at which the object accelerates? We're going to apply the same amount of force to each one. All right, so if we apply 400 newtons of force to each shopping cart, as we increase the mass, the acceleration should decrease. Okay? So as long as force remains the same, the force applied to the empty cart will not have the same effect of the same force applied to the full cart. So look, so if I push this empty cart, it's going to accelerate. All right? We're given force and mass. If we push an empty cart, it should accelerate with a greater velocity than if we pushed a full cart. If we calculate that out, we have 400 newtons of force divided by 400 kilograms. You get an acceleration of 1 meter per second squared. If you double the mass and apply the same amount of force, it's going to have the acceleration. And you'll see this when we work the problem out. So we still have 400 newtons of force applied to 800 kilograms of mass. That creates an acceleration rate of a half meter per second squared. Now, notice we doubled the mass, we have the acceleration. If we triple the mass, 1200 kilograms is 3 times more massive than 400 kilograms, you're going to get 1/3 of the acceleration. So if you have 400 newtons divided by 1200 kilograms, you get a rate of acceleration of 0.3333 meters per second squared. Due to inertia, meaning the object's mass, the full cart resists accelerating more than the empty cart because it has more mass. Like, look, you have a bunch of stuff in here. So the inertia, the mass, doesn't want to move. Inertia is directly related to mass. So an object that doesn't want to move will just sit there. Think about it like this. If you went outside and you had a bicycle sitting there and on training wheels, and you had a dump truck full of dirt sitting there in neutral, and you went up and pushed them both with the same force, the bicycle on training wheels will go flying across the parking lot. But the dump truck full of dirt, even though it's in neutral and no brakes are on it, you would push it and you're not even going to move it because it's got so much mass, which means so much inertia. It's resistant to change in its motion. Okay, and that brings us back to Newton's first law. So if you remember, Newton's second law said if you double the mass, you have the acceleration. If you triple the mass, you third the acceleration. It's an inverse proportion. So here you'll see, if the mass, acceleration, if you double the mass, you have the acceleration. You triple the mass, you third the acceleration. You quadruple the mass, you fourth the acceleration. So you'll see this is called an inverse proportion. Okay, if you have any questions, please feel free to ask. I'd be happy to clear any questions you have up for you in class. Have a great day. Take care.